Article 410.15 of the National Electrical Code, or NEC, specifically addresses the use of light poles as electrical enclosures and raceways. It's important to understand that this allowance is not a blanket approval for using just any hollow steel structure for electrical wiring. The code makes a distinction. While a light pole, under certain conditions, can be utilized as a conduit, a general hollow steel column requires further scrutiny. The NEC is very specific. The fact that the National Electrical Code allows the use of light poles as a raceway does not mean that you can just go and start using any metal structure for electrical wiring. There are specific conditions and requirements that must be met. So, in the scenario of using a 6-inch by 6-inch hollow steel column to supply power to the top of a permanently mounted umbrella-style canopy, several factors must be considered. Simply because the steel column is hollow does not automatically qualify it for use as a raceway. To determine whether the steel column can be legally and safely used as a conduit, one must consider a listing or field evaluation. The National Electrical Code requires that any equipment used in electrical installations be listed by a recognized testing laboratory. A listing means that the equipment has been tested and found to comply with the relevant safety standards. If the hollow steel column has not been specifically listed for use as a raceway, then it cannot be used as such. A field evaluation is an alternative to a listing. A field evaluation is an inspection and testing of the equipment that is performed by a qualified third party. The purpose of the field evaluation is to determine whether the equipment is safe to use and whether it complies with the relevant safety standards. If the field evaluation determines that the hollow steel column meets all of the requirements of Article 410.15 for light poles used as conduit, then it can be used as such. However, without a listing or field evaluation, it is not possible to determine if the hollow steel column meets all of the requirements of Article 410. One of the critical stipulations of Article 410.15 is that light poles can only be used as conduit for electrical conductors directly associated with the lighting of the light pole itself. This is a very important consideration. It means that the electrical conductors run inside the light pole must be dedicated to powering the light fixture or fixtures that are mounted in the pole. You cannot use the light pole to supply power to other equipment or devices that are not directly related to the lighting of the pole. In the case of the umbrella-style canopy, this means that you cannot use the hollow steel column to provide power to the top of the canopy unless the canopy itself is being used for lighting purposes. If the canopy is being used for other purposes, such as providing shade or shelter, then you will need to use a different method of providing power to the top of the canopy. If the intent is to provide power for lighting on the canopy, the column's suitability must still be verified through a listing or field evaluation. The absence of a listing or field evaluation leaves you unable to determine if it meets all the requirements of Article 410. It is also important to consider that even if the hollow steel column does meet the requirements of Article 410.15, there may be other restrictions or limitations on its use. For example, the local electrical inspector may have additional requirements that must be met. It is always a good idea to check with the local electrical inspector before using a hollow steel column as a raceway. If the hollow steel column does not meet the requirements of Article 410.15, or if it is not possible to obtain a listing or field evaluation, then you will need to use a different method of providing power to the top of the canopy. One option is to run the electrical conductors in a conduit that is attached to the outside of the hollow steel column. This is a common method of providing power to equipment that is mounted on structures that are not suitable for use as raceways. There are a variety of different types of conduit that can be used for this purpose. The type of conduit that you choose will depend on the specific application. For example, if the conduit will be exposed to the weather, then you will need to use a type of conduit that is suitable for outdoor use. If the conduit will be buried underground, then you will need to use a type of conduit that is suitable for direct burial. Some commonly used conduit types include rigid metal conduit, or RMC, intermediate metal conduit, or IMC, electrical metallic tubing, or IMT, and rigid polyvinyl chloride conduit, or PVC. Each type has its own advantages and disadvantages in terms of cost, durability, ease of installation, and suitability for different environments. When installing conduit on the outside of the hollow steel column, it is important to follow all of the applicable requirements of the National Electrical Code. This includes requirements for the support of the conduit, the grounding of the conduit, and the sealing of the conduit. It is also important to use the correct fittings and connectors for the type of conduit that you are using. Another option for providing power to the top of the canopy is to use a cable assembly that is specifically designed for outdoor use. These cable assemblies typically consist of a cable that is enclosed in a flexible, liquid-tight conduit. The cable assembly is then attached to the outside of the hollow steel column using clamps or other suitable hardware. When using a cable assembly, it is important to follow all of the applicable requirements of the National Electrical Code. This includes requirements for the support of the cable assembly, the grounding of the cable assembly, and the sealing of the cable assembly. It is also important to use the correct fittings and connectors for the type of cable assembly that you are using. Regardless of the method that you choose to provide power to the top of the canopy, it is important to ensure that the installation is performed in a safe and workmanlike manner. This means that you should follow all of the applicable requirements of the National Electrical Code and that you should use the correct tools and materials for the job. It is also important to have the installation inspected by a qualified electrical inspector to ensure that it complies with all of the applicable codes and regulations. In summary, while Article 410.15 permits the use of light poles as a raceway under very specific conditions, it does not extend this permission to all hollow steel structures. The key considerations are firstly, whether the steel column has been listed or field evaluated for use as a raceway. Secondly, whether the electrical conductors are associated with the lighting of the light pole, and thirdly, whether the installation complies with all of the other applicable requirements of the National Electrical Code. If you are not sure whether a particular hollow steel structure can be used as a raceway, then it is always best to consult with a qualified electrical inspector. Remember, safety should always be the top priority when working with electricity. Always consult with a licensed electrical contractor and verify with the local authority having jurisdiction prior to installation. Also, always ensure the structure is adequately grounded. Proper grounding is critical for safety. Grounding ensures that in the event of a fault, the electrical current will safely flow to ground, tripping a circuit breaker and preventing electrical shock. The National Electrical Code provides detailed requirements for grounding electrical systems and equipment. These requirements are designed to protect people and property from the hazards of electricity. When grounding a hollow steel column, it is important to use a grounding electrode that is sized appropriately for the electrical system. The grounding electrode should be connected to the steel column using a grounding conductor that is also sized appropriately for the electrical system. The grounding conductor should be installed in a manner that protects it from damage. It is also important to ensure that the grounding electrode is properly bonded to the building's grounding system. Bonding ensures that all of the metal parts of the building's electrical system are at the same electrical potential. This helps to prevent electrical shock in the event of a fault. The National Electrical Code provides detailed requirements for bonding electrical systems and equipment. These requirements are designed to protect people and property from the hazards of electricity. In addition to grounding and bonding, it is also important to protect the electrical conductors from physical damage. This can be done by installing the conductors in a conduit or other protective enclosure. The conduit or enclosure should be sized appropriately for the conductors that it will contain. The conduit or enclosure should be installed in a manner that protects it from damage. It is also important to ensure that the conduit or enclosure is properly sealed to prevent moisture from entering. Moisture can damage electrical conductors and can create a shock hazard. The National Electrical Code provides detailed requirements for protecting electrical conductors from physical damage. These requirements are designed to protect people and property from the hazards of electricity. And of course, ensure you are using appropriately rated conductors for the intended voltage and amperage. The conductors should be sized appropriately for the load that they will be carrying. The conductors should be installed in a manner that protects them from damage. It is also important to ensure that the conductors are properly insulated to prevent electrical shock. And consider the environmental factors like temperature. The National Electrical Code provides detailed requirements for the installation of electrical conductors. These requirements are designed to protect people and property from the hazards of electricity. The ampacity of a conductor is the maximum amount of current, measured in amps, that the conductor can carry continuously without exceeding its temperature rating. The ampacity of a conductor is determined by the size of the conductor, the type of insulation, and the ambient temperature. The National Electrical Code provides tables that list the ampacity of conductors for various conditions. When selecting a conductor for an electrical circuit, it is important to choose a conductor that has an ampacity that is sufficient for the load that the circuit will be carrying. If the conductor is too small, it will overheat and could cause a fire. The insulation of a conductor is the material that surrounds the conductor and prevents electrical current from flowing to other objects. The insulation of a conductor must be able to withstand the voltage of the circuit. The insulation must also be resistant to moisture, chemicals, and other environmental factors. The National Electrical Code provides detailed requirements for the installation of electrical conductors. When selecting a conductor for an electrical circuit, it is important to choose a conductor that has insulation that is appropriate for the application. If the insulation is not adequate, it could fail and cause an electrical shock or fire. So to summarize, when assessing if a hollow structure can be used as a raceway, don't just assume it's okay because it's hollow. Consider the NEC listing and testing the purpose of the wiring, grounding, protection, and conductor ratings. Always consult with a professional. The NEC is updated regularly, so staying current with the latest edition is crucial. Changes and revisions are made to address new technologies, safety concerns, and industry best practices. Familiarize yourself with these updates to ensure your electrical work complies with the most current standards. Electrical codes, such as the NEC, are not just a set of rules. They are the culmination of years of experience, research, and analysis of electrical incidents. They are designed to minimize the risk of electrical shock, fire, and other hazards. By understanding and following the NEC, you are contributing to a safer environment for yourself and others. The electrical industry is constantly evolving, with new technologies and techniques emerging all the time. Continuous learning is essential for staying up to date and providing the best possible service. Attend workshops, seminars, and training courses to expand your knowledge and skills. Consider obtaining certifications to demonstrate your competence and commitment to quality. Engage with other professionals in the field to share ideas and learn from their experiences. There are many resources available to help you learn more about electrical safety and the NEC. The National Fire Protection Association, or NFPA, which publishes the NEC, offers a wide range of training materials, publications, and online resources. Many other organizations, such as the Independent Electrical Contractors, or IC, and the National Electrical Contractors Association, or NECA, also provide valuable information and training. Take advantage of these resources to expand your knowledge and skills. Always prioritize safety in all of your electrical work. Electricity can be dangerous, and even a small mistake can have serious consequences. By following the NEC, using the correct tools and materials, and taking the time to do the job right, you can help to prevent accidents and ensure that your electrical work is safe and reliable. Remember, when in doubt, consult with a qualified electrical inspector or engineer. They can provide guidance and ensure that your electrical work complies with all of the applicable codes and regulations. Their expertise can help you avoid costly mistakes and ensure the safety of your electrical installation.